Hello, we're going to look at solving trig equations day 2. We're going to add a couple more questions on today, looking at some other ways to solve. So here is our first one, example 1. We're going to solve secant of x equals the square root of 2. Now, there are lots of different ways that we could solve this. We could graph it, all sorts of things. We're going to solve it algebraically. And we remember that secant of x is equal to 1 over cosine of x. And I also know I can multiply both sides by cosine, divide by secant. So cosine of x equals 1 over secant of x. So I know secant is 1 over cosine, so I could do 1 over x with my unit circle. But I want to write this in terms of cosine because it's just easier for me to understand that way. So if this equals cosine, then, and cosine is 1 over secant, and secant equals square root of 2, then I can say that cosine equals 1 over square root of 2. Okay? So I'm just substituting those things in. Alright, so cosine, secant equals 1 over cosine. I can solve, I get 1 over square root of 2. And then I would have to rationalize my denominator. So multiply top and bottom by square root of 2. So I get cosine of x equals square root of 2 over 2. And we're going to do all of these today in the interval of 0 to 2 pi. So we'll restrict all of our domains for every question today to that interval. Okay? So cosine, so we're looking at the unit circle. You should have gotten one today that you could keep. So where is cosine square root of 2 over 2? X would equal pi over 4. And then cosine is x, so also 7 pi over 4. And those would be our answers. Okay? Number 2, let's look at another one. Now what if this question, it got extended? So what if we had tangent of x, cosecant of x equals 2 tangent of x? Okay? Well, now we have equations on both sides. I could graph them, but again, we're not going to use our calculator for this standard as well. So I'm going to solve it algebraically. So tangent of x, cosecant of x, and this is a positive 2 tangent of x, so I'm going to minus 2 tangent of x on both sides. I'll move it, it gets equal to 0. Now I notice I have tangents, I have 2 tangents on the left side here, so I can factor those out. So when I factor them, I have tangent of x times cosecant of x minus 2 equals 0. So here's an example similar to that. If I had xy minus 2x equals 0, how I could solve for this is I could factor out an x here, right? I'd be left with y, because 2 times y would get me back to that, minus 2 equals 0. Then we remember that we have to set each of these factors in equal to 0, and then solve for each of them. So we would get these 2 different answers for this example. But we're going to do that same thing here. So we'll set tangent of x equal to 0, and then cosecant of x minus 2 equal to 0. Now tangent equals 0. Tangent again, we have tangent of x equals sine over cosine, so it's y over x. So looking at our unit circle, where do we get 0 rather than undefined? When we have 0 over 1 or 0 over negative 1. So tangent equals 0 at 0, at pi, and at 2 pi. And we would include 0 and 2 pi because it's our domain we restricted at the beginning, including 0 and 2 pi. So that's why we want to have both of those answers. And then cosecant we could say, okay, cosecant of x equals, and add our 2. Now, cosecant is equal to 1 over sine of x. So to show a couple more steps here, I could switch this and say 1 over sine of x equals 2. I could multiply both sides by sine of x, and then I end up with sine of x equals 1/2. So this is similar to the first question we did. I just showed some other steps. Some of you may be able to go right from here to here. That's totally fine. Some of you need all the steps. That's fine too. So let's look between 0 and 2 pi. Sine goes with y. So where is y 1/2? Well, we get pi over 6. And then a positive 1/2 again for our y, so we get 5 pi over 6. So our answers are right here and right here. So all 5 of those are correct, and all 5 of those are our answers to this question. Okay? All right, let's look at another one. We're still going to go with the domain of 0 to 2 pi. So number 3. We have 3 secant squared of x minus 4 equals 0. All right, so we're going to add our 4. So 3 secant squared of x equals 4. Divide by our 3. Then we'll take our square root of both sides. Remember, when we take our square root, we have to add the plus or minus out front. And now I'm going to do a couple steps in here. So the square root, I'll show them, but I'll erase them. So we'll do the square root of 4 over the square root of 3. Square root of 4, we know that that is plus or minus 2. The plus or minus is already out there. So we can just write 2 over square root of 3. Now, I know I'll have to rationalize the denominator, but I also have this in terms of secant, and I want it in sine, cosine, or tangent. So I remember that if that secant is 1 over cosine, so cosine of x will be the reciprocal of this, so I'll get square root of 3 over 2. Now, if you want to show those steps like we had from before, you should end up at the same spot. So you're welcome to do that. And then let's look on our unit circle. So x in this case, we want all of the x values that are positive and negative square root of 3 over 2. So we get pi over 6. Positives and negatives. So 5 pi over 6, 7 pi over 6, and 11 pi over 6. And we were looking at the cosine, right? So that would be our x values. And since it's just restricting that domain, we only have those 4. Okay? All right, now here's another one. Example 4. This should be our last example. Example 4. If we have cosine squared of x, or no, cotangent. Let's go with cotangent. Cotangent squared of x equals negative 2 cotangent of x minus 1. Now notice this is a quadratic, right? So I'm going to mirror this if it was written as x squared equals negative 2x minus 1. So it's similar, but instead of just x's as variables, we have this trig function as well. So what we would do here is we'd say, okay, let's move everything over so that we're equaling to 0. So we're going to do the same thing here. Cotangent squared of x plus 2 cotangent of x plus 1 equals 0. Now, we're going to think about this quadratic, and some of you are able to do this in your head. You're thinking, what multiplies to give me 1, adds to give me 2? Well, we know we got 1 and 1, so therefore we have x plus 1, x plus 1 equals 0. So if I FOIL this back out or distribute each term, I should be able to get what I had originally here, right? So x times x, x squared, 1x plus 1x is 2x, 1 times 1 is 1. So then I would set each of those factors equal to 0 again. So similarly in my equation here, I'm doing the same thing. So I'm also using this idea And we could do where we split up this middle term and do left side, right side, but we noticed that there was a pattern. When our leading coefficient was 1, that whatever we got for R and S, that's what we would put in our two factors. So that trick you should know by now. If not, we can work through some of those questions. But we have, so in this question we'll have cotangent of x plus 1 and cotangent of x plus 1 equals 0. And the way that I found that is by doing this stuff in red over here. So then I can set this equal to 0. And since they're the same, I really just have to do it one time. So I'm looking for when is cotangent of x equal to -1. So cotangent, remember cotangent is equal to cosine over sine, or x over y. Because we had tangent before, tangent was sine over cosine, or y over x. So where is x over y equal to -1? So remember where tangent is equal to 1 at pi over 4. So then where would it be equal to -1? And this one, we could also flip it and relate it back to tangent, right? But because cotangent is just the reciprocal, it should still work for us. So our answer for x, we get 3 pi over 4 and 7 pi over 4. So cotangent, where is that negative? And in this case, it would also work for our tangent, right? Because we're just switching those around. So here are 4 examples that are a little more complex with solving, but they're just applying some algebra skills that we've already learned. So we'll use that to help us with our next practice. See you then.